AP Physics, page 53, homework, problem number 45. This is really a simple perspectives question. We really don't need to worry about projectile motion so much here. The side view right here is really not that important to us. If we had to find components or how high the projectile went, it'd be a different story, because in the vertical direction we have acceleration. But if you simply view this thing from overhead, so we have an overhead view, so if you're above, the sun shining straight down, all you would see is the shadow, or even the cannonball, goes straight horizontally. You wouldn't see the arc if you're looking at it from above. That's what the problem is referring to, directly overhead, looking straight down. The shadow, and that's kind of one of the principles of projectile motion. The horizontal motion is independent of the vertical up and down motion. It's traveling at a constant speed, constant velocity, particularly horizontally. So bottom line is it's going 600 meters horizontally. That's the displacement, that's the distance, both, in a time of 3 seconds. So the average velocity sideways is 200 meters per second. That's actually a constant velocity. At all times, it's going that speed sideways. Now, up and down, it's going a different speed than that. Its overall speed or velocity is more than that because it has a greater speed, except, well, at the very, very top of the motion, say up here at the pinnacle, at the apex, it's going sideways at that speed, at that time, at that instant as well. But the shadow is always going that speed sideways, horizontally. So that is the answer to parts A and B. The instantaneous velocity at all times is this. The average velocity sideways, horizontally, is always that. And that's the answer for parts A and B.